Welcome and thank you for joining us for another episode of the Jain Irrigation Training Series. I'm Richard Restuccia, Vice President of Water Management Solutions for Jain. And today we're going to be talking about something that I feel isn't talked about enough yet, but we're starting to see the conversations happen. And it's the switch from 3G, because it's being sunsetted, to 4G or 5G. And who knows the difference between 4G and 5G? And more importantly, what is more important for you and your application or your task? And that's really what we're going to do today is we're going to help you understand, should you be moving to 4G? Is that better for you than 5G? And really, what's the difference between the two so you can make a more informed decision? And helping us on this journey today is Kurt Ahart and Rob Moore from Minneapolis-based Digi International. And let me tell you, I've got to know these guys quite a bit over the last few weeks, and I've really learned a ton from them. You know, Kurt has been involved in technology for, I say, pushing 40 years. I mean, that's really incredible. And he joined Digi back in 2003 and has held quite a variety of important positions there. And the thing I really enjoy about Kurt and Rob both is they do a really good job at explaining a complex technology in a way that I can understand, and that means most people. So that's really great. So Kurt, welcome and thanks for joining us today. And then also with us is Rob Moore, who has been at Digi for a long time too, right, Kurt? Almost 20 years, and Rob, you joined in 2005. So again, somebody who's really been around technology for a long time, working in sales and product development. Rob's done quite a bit of work in the agricultural area too. So these guys are just perfect for our presentation today. So again, thanks guys for joining us. Glad you guys are here.
You're welcome.
Yeah, thanks for having us.
Yeah, so Kurt, I wanted to start with you, and I just wanted to ask you, for those of us who don't know much about Digi International, tell us a little bit about the company, how they're supporting cellular communications, and more importantly, why we should be listening to you guys about this important subject.
Thank you. So as we mentioned up front, we are headquartered in Minneapolis, actually in Hopkins. And for those of you that may be interested, it's also the place where Eric Olson, the president of Jain, is from originally. I don't know if you guys knew that. We were founded back in 1985. The company has always been in what we call the Internet of Things space. We made a pivot back in about 2003, around the time that I joined the company, into the wireless Internet of Things space. And it really catapulted our growth really over the last 20 years. Digi itself has about 700 employees. We are a global company. So the technologies that we provide to our customers generally are used and work around the world. We have offices and we have R&D facilities around the world. We've been profitable now for 18 years straight, and that's through, now I guess it's been 3 recessions. And that's pretty unique in the Internet of Things space. We are about a $300 million company. We're having a great year if you follow our earnings, and we are traded on the NASDAQ under the symbol DGII.
Kurt, I had a quick question here. 18 years of profitability, that's a great number, and that is a big number. Congratulations. What happened prior to the past 18 years? Did you guys struggle? Did you have, a bunch of good years and a bad year and then a bunch of good years? What was that like?
Well, Digi went public about 1987. At the time, they were the Digi board company, and they made boards that went into primarily Intel-based computers that allow you to string many devices into a network. And these were used in a wide variety of industrial applications. The company grew rapidly, and then in the late 1990s, the world kind of pivoted, and at the same time, we had, the dot-com bust, and the company kind of lost itself, and a new leadership team came in, which I became a part of, that turned the company around into the wireless space. And that, reignited the company. At one time, we were down to $100 million of revenue. And we, quickly grew through both organic and acquisitions, betting heavily on the wireless space, which turned out to be a very good decision for the company.
Yeah, good for you guys. That's a pretty exceptional turnaround, and very exciting to hear about and see. So, Kurt, who are your customers? Who is buying your equipment?
So Digi makes horizontal technologies, and our wireless IoT solutions are delivered by our sales teams into vertical markets. And I'm showing a number of the markets that we play in. So we take these horizontal technologies, and then we tweak or customize those into products that fit specifically into verticals. One of the great things about our business, and this is one of the things that helps us stay profitable, is through various downturns in the economy, and we can use COVID as an example. Some markets may take hits, but other markets may grow. So during the COVID time in the energy sector, places like oil and gas, we saw a decline rapidly, but places like medical and precision ag and ag automation grew. So we have that great balance in our business, and that gives us a lot of stability, and our customers appreciate that stability of our company.
I bet this is what a nice resume of customers you have here. This is a great who's who slide to show. I love this.
Thank you.
So then, can you tell us about more about your customers, who you work with, and how they use your product?
Yeah, typically we're used in applications where people are trying to connect the physical world to the digital world. And in many cases, those devices weren't created to be connected. So we provide the technologies that allow them to be connected using wireless. And since we are talking about irrigation, we'll just show you an example. This is a typical irrigation customer of Digi's. In this case, we're showing the example of a pivot system. And those little green lines are wireless connectivity. So we're showing local devices using local radio technologies to connect things like weather stations, soil moisture sensors, and the pivot, all in a local environment. And then we're providing local control through a barn or a farmhouse or an equipment shed using that local wireless communications. But we're also using wide area communications from the farm, in this case, cellular technologies, to connect to the cloud. And this allows our customers to deliver things like web-based applications and mobile applications using cloud technologies.
And so in this, and I love this diagram, right? I call it my Farmville diagram. Where's Digi? They're in every one of those green points, the green circles.
Yeah, and in this case, these may be different manufacturers. It may be a solutions provider that's putting things together. Could be a dealer that's assembling a system, or it could be a pivot manufacturer that's vertically integrated and providing all those components, many of which they may source from others. But our secret sauce, or our glue, is the ability to connect those things wirelessly together into a system. And we do that in a very simple, easy to use and secure method.
Yeah, and then in this diagram, right, what is the pivot could also be a Jain C3 telecommunications device or a telemetry device, picking up information from soil sensors, weather stations, sending it up to the cloud and making all this communication possible.
Absolutely. The pivot in this case is the controller. It could be a controller for any kind of irrigation system, you know, a drip system, a lateral system. The use case would basically be, you know, be the same in all those examples.
Yeah. Great, thank you. Rob, I have a question for you now. And I know that recently Digi's been supporting IoT device makers that have embedded cellular products. What made you guys make this shift? Why do you think that's the place to be? And what does your product do for them?
Great, yeah. If you could advance the next slide, Kurt. I'll start with some background on Digi's support of embedded IoT device makers to address the question and introduce you to the XBEE product family. So Digi introduced the XBEE wireless communication module 15 years ago. As you can see here, the different variations of this product support various communications protocols. We started with Zigbee. We added sub-gigahertz proprietary protocols to that, and have supported a lot of customers with these protocols in the agriculture and irrigation spaces specifically. In the top left corner there, you'll see a cellular protocol that may or may not be familiar to you under that LTE heading, and that's LTE-M. So that's one that we'll kind of focus on as we talk about the requirements of IoT device makers. Want to advance the next slide, Kurt? So whatever version of XBEE a customer works with, whether it is one of our new cellular variants or one of our long-term that we've offered in the RF space for Zigbee or sub-gigahertz, they all share the same pinout, so they're all hardware swappable, and they all share the same software API, so they are all software swappable as well. Want to hit the next slide, Kurt?
Yeah, so Rob, help us out a second. What is a Digi XBEE? What exactly is that?
So it's a simple and certified hardware module or modem that allows for communication from a remote device. So in the very early days of Digi, we were offering these to a lot of sensor manufacturers, a lot of people in the agriculture space that may have been communicating wirelessly on a farm, like on that diagram that Kurt showed you. So it's the easiest, quickest method for a device maker to get to market and not have to worry about, especially the certification requirements that come, especially for deployments around the world where there's a lot of regulatory agencies that have to be navigated through.
I see. Okay. Yeah, thank you.
What I wanted to get to then to answer your question is specifically the cellular piece that we started offering in 2017. So this is the XBEE cellular product. We introduced this in response to a change in what device makers were asking for, which in turn was a response to changes in what the cellular carriers started offering that made embedded cellular much more attractive to IoT device makers. In North America, Verizon and AT&T announced at that time support for the new LTE-M protocol. Now LTE-M, I first introduced you a couple slides back. That's a category of 4G LTE protocol that is specifically designed to support the requirements of machines and enable carriers to support large numbers of machines that are connected to their network. LTE-M supports a lower speed over the air than what you're used to a typical LTE, so it's about 375 kilobits per second. But this generally matches to the requirements of IoT devices, which have real low data requirements, where they're sending small amounts of data, and usually it's infrequent. One of the advantages this offers to device makers is that it enables longer distances between that device and the tower, so that lower data rate actually improves receiver sensitivity, which bottom line is you can have a lot more distance between your device and that tower than maybe you could with your phone, which has a real high bandwidth.
Yeah, so Rob, help me out here. I'm looking at my phone, and I know it is a 4G phone. It's not 5G capable, but sometimes I see 5G come up on my display. What's happening there?
Yeah, so we'll probably talk about that a little bit more later too, but what we're seeing right now is carriers that are adding 5G capabilities, rolling that out around the country. So Within the United States, North America, LTE 4G technology is quite common and ubiquitous. 5G not so much. So phones now are actually being built with radios, chipsets in them that can communicate with both 4G and 5G. Where that's really important on the phone set is for when you're working with high bandwidth applications like downloading video, for example, maybe monitoring your video stream from your surveillance camera on your doorbell or something along those lines, where that higher speed's real critical.
I see. Okay, that certainly helps. Thank you. And then this is a picture down. So Kurt was showing us the modem, and then this is a picture of it down on the bottom right-hand corner of the slide.
Exactly. So what that represents is an end device certified cellular modem. And end device certified means basically that the cellular carriers in North America have already certified that as a cellular device on their network. That's critical because anytime you're introducing a cellular device that's going to connect to Verizon or AT&T, whether it's a phone or whether it's a device inside your home, Verizon and AT&T want to certify that device for their network so they can ensure minimum levels of performance. We've taken that part of the design risk out of the hands of the IoT device makers. They don't have to worry about that, and it reduces the risk and makes it much more easy to get to market.
Okay. All right. Great. Yeah. Thank you.
And then the last point here I want to point to on our XBEE is what I mentioned earlier, the 900 megahertz. I throw this in here because we see customers deploying agricultural devices around the world, a lot of times to locations where there is not cellular network coverage. So in that case, 900 megahertz, the XBEE SX can cover large distances and connect those remote devices back to a gateway, which then is usually located in a place with cellular or Ethernet connectivity. So that simply provides another option for customers that are working with XBEE for locations where cell coverage may not be available.
So that's great. Very interesting. I want to ask Kurt now. You've been around a long time in technology. I think 3G has been around maybe since the late 90s, 2G a little before that. How did we move forward? What's that path looked like, and what's it going to look like?
Great question. I've got a chart here that I'm showing, and this is basically showing the evolution from 2G to 5G today. And you also see on the second row above the technologies, you see the corresponding speeds that these networks are delivering. So as you can see, over the years, we've gone from actually in the analog below 10 megabits per second to now we're talking about gigabits per second. And in some cases in metropolitan areas where they're deploying a millimeter wave technology, we're seeing speeds up to 10 gig. So really quantum leaps. From a timeline perspective, we're showing back in 1979, the first standards were ratified for analog. And if you're not familiar with standards organizations, there's an organization called the 3G PP, which is a third generation partnership organization. It was actually formed around the 3G time. And they write the technical standards that the various regional standards organizations will eventually adopt and ratify and create standards that the mobile operators can build networks around. So back in 1979, the first analog spec was written. And this is kind of an interesting trivia question. In 1983, the first cellular service was launched in Chicago by a company called Ameritech, if anybody remembers those from that time. And people had those big phones, in a lot of cases, those big bag phones that they were hauling around way back then. So as you can see, there's a lag between the standard and when commercial services are actually launched. So as we look across here, 2G came out in 1991, and 3G came out in 1998. And as we'll see shortly, we'll talk about this, but 3G is being sunsetted in early 2022. The first 3G networks actually came out in about 2002. So roughly a 20-year life cycle for that technology, which is really quite a long time. I'm showing also on this when Digi entered the market back in 2004. We introduced the industry's first cellular router, a commercial industrial cellular router, and I actually fished these out. There are a couple of trade show devices that I found in one of my cabinets. One's a clear one showing the inside, and this is kind of what the actual product looked like. But we were a pioneer in the wireless IoT space at that time, and have been delivering products in similar form factors over many generations and millions and millions of devices. 4G, the standards were ratified in 2008, and that technology was rolled out in about the 2010 timeframe. And you can see 5G was ratified in 2019, and commercial deployments started in 2020. In fact, the operators are getting a little faster at the game and the race of delivering the technologies. If we look at 4G, which Rob said is really the most pervasive technology out there in the market right now, we can look at various categories and speed requirements within that technology. So at the low end, Rob was talking about LTE-M and NB-IoT, which were really brought out by the mobile operators in 4G to support a mass of internet devices or IoT devices. And the bandwidths that they have are sufficient for the traffic that's needed. In fact, it's very comparable to the previous generation with 3G. Stepping above that, we have Cat 1 all the way to Cat 20. And as you can see, the applications in the bottom, as Rob was describing, we start looking at things like video, applications where control is important, applications where large pieces of data need to be moved. And in those cases, you need much higher speed and much higher latency, or excuse me, lower latency for those types of applications. But if we look in the lower left box, really where things like irrigation control fit is around sensors and really simple control applications. In fact, it's very rare that you'd ever be moving much data at all, with maybe the exception of updating software on a controller.
So Kurt, we've got a question coming in from one of our viewers, and they're asking, 2G and 3G were allowed to operate at the same time, but now 3G isn't allowed to operate with 4G or 5G. Is this a bandwidth issue? Is bandwidth finite?
So it's about frequencies. So the way networks get deployed, our mobile operators bid on license frequencies, and you'll see these coming up regularly where frequencies are released, and the operators bid, and then they get, could be 700 megahertz or 2.5 gigahertz, and now we've got a number of networks in the 3.5 gigahertz, but they buy those licenses to deliver their services, and that frequency that's their goal, and it has. What they're trying to do is they're trying to maximize their investment on that technology that they're deploying and those licenses that they purchase. What's interesting is the original networks of 2G and 3G, there was no spectral sharing. So you couldn't take frequency and allocate that across multiple technologies to support current devices and legacy devices. In the case that we were just discussing, 2G and 3G. What's unique about 5G is 5G offers the ability to support both 4G technologies as well as 5G technologies in the same frequencies. So the software and the network has the ability to dynamically allocate that frequency and support both of those devices in harmony, if you will, both types of devices. So, and I'll show a chart in a second. One of the questions though that we need to address is for those of us that have 2G and 3G devices deployed, what's going to happen? So I think everyone knows that 2G is mostly turned down with some exceptions with Verizon, but all the mobile operators here in North America announced sunset dates where they're going to be retiring that spectrum and using it in their new networks. And I was asked a question when we were getting ready for this webinar, whether those dates will be extended. I believe that's a possibility, and one of the things that was discussed is some of the supply chain issues in getting the new technologies to OEMs that put that in equipment, that sell that to customers, particularly in important applications, maybe like security systems. So we may see some of those dates change, but the mobile operators are also highly incented to move that frequency to the new technology because of efficiency and cost and the ability to generate more revenue from their investments. So we shall wait and see, but we probably need to plan for the sunset dates to be off the current network technologies and onto the new technologies.
Yeah, so I think the sunset date for AT&T 3G is coming up February of 22, just a few months away. But even if they push back, nobody's talking about pushing back any further than the end of 2022. Is that correct?
I don't have any more information than those dates right now. So, the only thing that can change this is potentially where, a potentially large customer with lots of connections wields their weight and uses that leverage to make changes. But as I shared, I mean, they're heavily incented to get to the new technology, cost savings, and the ability to generate new revenue.
Right. And 220 million customers with 3G devices today, or something close to that. But so we're moving to 4G, and this question's for you, Rob. The 4G to 5G, what does this mean for Internet of Things applications?
So for device makers that are putting 4G today into their devices, the transition to 5G will really mean very little. The really important thing for device makers to understand is that the two key technologies for machines that are part of 4G, that is the LTE-M protocol and NB-IoT, those have already been included by the 3GPP organization into the 5G protocol definition. So these are the first cellular categories specific for machines, and 5G will carry over support for LTE-M and NB-IoT. So what that really means is the best place to focus for device makers today is 4G, knowing that it has a lot of life in it, potentially to 2030 or later. And beyond that, when 5G starts rolling out, or when 4G goes away and 5G is what's left, they'll know that their LTE-M and NB-IoT devices still have life and legs in them as long as 5G is around. So the horizon for these devices going on to LTE-M and NB-IoT is potentially a lot longer than a similar device getting a 3G radio in it years ago.
Okay, so if I'm a customer moving from 3G to 4G, but I hear about this 5G out there, I should still feel okay that I'm moving, or feel good that I'm moving to 4G, and I can feel confident it's going to be around for a long time.
Right, that's exactly right, and it's an interesting question when I'm working with engineers that are designing an XBEE cellular device into their box. They come to me with questions from their marketing teams saying, I've seen all of this information from the carriers about 5G. Did you have a 5G device? And my message back is that Digi LTE-M or NB-IoT device is basically 5G, so they've got 5G today.
Yeah, that's a great point. I think, and not enough people are making it. I don't think so. Kurt, you had a slide up earlier. It showed like a city, and I wanted to understand also though the benefits of 5G for the marketplace. You know, why do we have 5G? What do people expect to get out of that?
So there's some really interesting things that are happening with the use of 5G technologies. And, you know, I'll give you a couple of examples. So you brought up the city, which is kind of an interesting one, and a common application of wireless technologies in cities could be video surveillance. One of the things that we have going on here in Minneapolis is the lack of police, unfortunately. And in fact, we have election coming up about, you know, funding for the police department and what direction that's going to take. And we've had an increase in crime over the last year as the numbers of officers on the street has dwindled. But taking something like 5G technology would allow you to put up video surveillance cameras in more places in an economical manner and provide, you know, real-time information from the street to the operations center for a public safety department. Another application is what people are calling Industry 4.0, or in the manufacturing sector. And what we're seeing is a movement from wired technologies to wireless technologies, and moving away from Wi-Fi, which has a lot of limitations from a scaling and a security perspective, into using cellular technologies within the factory. And this gives a customer or a manufacturer the ability to rapidly change their manufacturing configurations and lines as they introduce new products, and gives them the ability to very economically and quickly reset up a factory without pulling expensive cables and access points and those sorts of things. And you wouldn't have been able to do that with a 2G, 3G, and probably a 4G technology, because you need very high speed and low latency for those types of application where you're doing really what is manufacturing process control. So those are some of the applications and the benefits where you have very high speed and the things you could do that you couldn't do before with the previous cellular technologies.
Yeah, so it's a lot about the high speed definition of video.
Mm-hmm.
We actually want to see the person, not just see the shadow of a person.
Yes, and then you'll hear a lot about. We have a lot of customers now that are starting to do things with what's called machine vision, which is basically taking visual applications for video and images, and then using machines to process that data to determine things, for instance, like a quality of a part coming off of a manufacturing line, using a camera to inspect that for quality. So you need images which require a lot of data. You need speed to get that to a machine that can do the processing. It could be in the cloud or it could be in the edge. And those things are enabled by that type of high-speed technology.
Okay, great. That's very interesting. So, Rob, you've got a lot of experience with irrigation applications now, and if I'm a user of irrigation technology and I'm thinking about 4G or 5G, what should I be thinking about? Which would be best for me?
Yeah, so device makers, they need to look at what their requirements are that will impact cellular technology selection. So really today what that means is how much of a data pipe do I need? How much data do I need to move at a time? So generally irrigation applications match to what the LTE-M protocol was designed to address. That is low data requirements, infrequent transmissions. 4G LTE-M also, as I mentioned, increases range from the device to the tower. So for these applications that are not in city centers where there's a dense population of cell towers, we'll literally be able to take advantage as well of that longer range between the 4G LTE-M radio and that cellular tower. So that's another positive characteristic of LTE-M, and the reason why I point my customers in the irrigation space and agriculture to that as a starting place. It fits the requirements. From a cost perspective, it's more attractive because it's designed for machine applications. And as we talked about before, it's got a lot of legs on it. The technology itself is expected to be supported by the carriers through the 5G transition.
That's great. So, and then I think I know that with the 4G device, I think it's like a 65-mile line of sight connection capability.
So the 900 megahertz can certainly get up to that kind of range. With the 4G LTE-M, it's going to depend on various factors, but significant ranges are definitely supported. And the interesting thing there is when your phone says it can't connect any longer, with its LTE connection, potentially that Cat-M is going to still have a lot of range that it can still use to reach that tower from distances greater than your phone could.
And then if you do, a lot of our ag applications have line of sight issues. Is there something that they can be done, something like a mesh network or something like this?
Yeah, and that's where that 900 megahertz radio that I mentioned to you is probably going to be really attractive for those spots that don't have good cell coverage. You could use a gateway. Digi manufactures gateways that would go from the 900 megahertz to cellular. And on that 900 megahertz side, as you mentioned, meshing is a technology we've been supporting for a lot of years. So if you have a number of these devices in a given geographic area, then each one of those radios can basically act as a repeater for one that's more distant from it to get that data back to that collection point where you have network connectivity.
Yeah, that would be super helpful for a lot of our customers. Could definitely use that. So we have a couple other questions coming in, and Kurt, I'll let you take this one. Someone's very appreciative of the training, but they want to know the shift from 3G to 4G. Is this the service providers that are doing this, or is this something that's coming from the government?
It's really coming from the service providers. They're in the battle or in the race to one up one another for revenue and profitability. I think one of the things that you'll see is there's a number of mobile operators that aren't the household names, and they're typically in the rural parts of the United States. So if you take a cross-country road trip, you're going to go into coverage of some operators that wouldn't be familiar or household names, but provide local service in an area. And generally, they're going to be lagging what the major mobile operators with, the more ubiquitous coverage will do. And so it's more of a, keep up with the Joneses, provide the latest and greatest faster services than it is, a government mandate.
Yeah, good answer. Thank you. So a couple more here. One person's asking about is the Digi XBEE competing product to Wi-Fi gear. Why don't you take that, Rob?
Sorry, can you repeat that?
Yeah, so is the Digi XBEE a competing product to Wi-Fi?
Yeah, in some ways. We do have an XBEE Wi-Fi variant for applications where it makes sense to connect to an existing Wi-Fi infrastructure. Most of the time, I'd say we're not competing. We're going into application types that maybe are not best addressed by Wi-Fi. For example, out in a farm or rural agricultural type application where there isn't Wi-Fi infrastructure and it may be expensive to deploy that, that's where a long distance 900 megahertz makes sense. XBEE ZigBee actually coexists pretty well with Wi-Fi in some hospital environments. And of course, cellular has a whole different fit for itself where Wi-Fi may not be ideal but you can rely on the existing infrastructure that a T-Mobile or AT&T or Verizon have put in place.
Yeah, thank you. Yeah, great. So then, Kurt, here's the last question, might be the million-dollar question, right? And that is, how long is 4G going to last?
So that's a good question. I think we have at least a decade and probably much farther than that. As we watch the standards and what's going on, is 5G is going to support both, as we said, both 4 and 5 on the same network, sharing frequencies. And for IoT devices, the carrier's preferred solution, just because of the scale and efficiency and RF performance that Rob was describing, Cat-M and NB-IoT are really the preferred delivery vehicles for those services that are, typically the lower bandwidth types of applications.
Yeah, so I think that's if I'm getting this correct, the key is 4G and 5G can coexist for a long time.
Mm-hmm.
Yeah. Okay. Well, listen, you guys, this has been really informative, very interesting. I really appreciate your time that you spent preparing and getting ready for this, and then, of course, the time to present it. I love that you have this slide. I know that you're okay with people reaching out to you. If they have questions, they can email you at these email addresses and get some additional clarifications or share some ideas with you if they'd like, correct?
Certainly.
Absolutely.
Yeah. So anyway, thank you again. And thanks to all the viewers today. We really appreciate you taking time to spend your lunch hour with us. Remember, all of our trainings are at the janesusa.com website /trainings. You'll see about 150 of them there now. And please enjoy those. There's no charge to watch those. And as the year is coming to an end, we have quite a few that of our presentations that qualify for CEUs with the Irrigation Association. So here's your chance to take a look at those and get credit with the IA for watching those. Keep all your certifications up to date. We're also, wherever you listen to your favorite podcast, right? We extract the audio out of this, and I know a lot of people are listening to those as they drive to job or sometimes out for a walk or a jog. So we appreciate that too. So again, Rob, Kurt, thanks very much. Appreciate your time today. And thanks to all of you for joining us. We'll see you next week. Thanks.
Thank you.
Thank you.